integral 0 to a f of x here, f of 2a minus x. In case these two are equal, this is becomes like this, 2 times of 0 to a f of x dx, right? 2 times of 0 to a f of x. So 0 to 2a f of x can be written as 2 times of 0 to f of x dx, and when f of 2a minus x is equal to f of x. In case f of 2a minus x is equal to minus f of x, means this plus, this is minus, it will become a 0, plus minus. Okay, and here this condition I already explained. When the function is even function, 2 times of 0 to a. When limits are same and opposite sign, I told you like the given function is odd function, the integral becomes 0. Remember students. Okay, remember that. So proofs are there, proofs are not required. Okay, like already we started this exercise. Uh, so what are the problems we completed? Students,
Till 5, sir.
till 5.
Sir,
Okay.
we also did 18.
Yeah, I also done the 18th one. Yeah, fine. Like I explained, 5th one, 6th one, as well as 18th one. Am I right? Is it clear, students? Here, x minus 5. X minus 5 means, say x minus 5 is equal to 0 means x is equal to 5. Nothing but what? Here, you have to split the function like, okay, if it is plus 5, no problem. But here it is a minus 5. So that we can split the interval 2 to 5 plus 5 to finally 8. Here is minus of x minus 5, here plus of x minus 5. Okay, this one. Clear, students? X minus 5 equating to 0, x is equal to 5. 2 to 8 you can split into 2 to 5, 5 to 8. That's all. So then after you can do it. Let us do eighth one. Eighth one is the important one. Okay, here few questions are there, very important and quite lengthy. In that one of the question is eighth one and 10th one. Lengthy one is like 12th one. Okay, remaining okay, easy one, right? First let us do the eighth one. Right. So was the given question, I is equal to integral from way to a 0 to pi by 4, 0 to pi by 4 or log of 1 plus tan x into dx. Got it? This is equation 1. Okay, so here since I want to apply the property, I told you property 4 is very important, like 0 to a f of x dx is equal to integral 0 to a f of a minus x dx. So in what are the questions we can use that property for? First question, second question, third question, fourth one, as well as ninth one, eighth one, 10th one. Okay, property 4 alone, 12th one, and okay, 17th one, 16th one, 15th one. Okay, these are in these questions we will apply the property 4, that is 0 to a f of x dx is equal to f of a minus x. This a minus x we can replace here, right? 0 plus a is a minus x, like that. This is the special case of property 3. Okay, anyhow, right. So I is equal to, when I apply the property, 0 to pi by 4 log 1 plus in place of x tan pi by 4 minus x dx. Okay, this is same as tan a minus b. What is the tan a minus b formula? Apply tan a minus b, 0 to pi by 4 log mod 1 plus tan pi by 4 minus tan a minus tan b by 1 plus tan a into tan b. Okay, this is about tan a minus b formula. This is modulus. Okay, fine. Now into dx. Now what is tan pi by 4? Tan pi by 4 is clearly 1, 1. So denominator is 1 plus tan x. You can take LCM 1 plus tan x. Take LCM here 1 plus tan x. So when I take the LCM is 1 plus tan x here, 1 plus tan x plus 1 minus tan x into dx. This is equal to integral 0 to pi by 4 log mod. Yeah, tan x get cancelled. This is 2 by 1 plus tan x dx plus. No need to write plus because this is a definite integration. So this is in the form of log a by b. Again apply the formula for log a by b. So pi by 2 log. So what is the formula? Log a minus log b. Log of 1 plus tan x. So left side is clearly I like into dx. See students, I am going to apply log integral separately. So log 2 is a constant. Take it outside. Integral 0 to pi by 2 or pi by 4? Pi by 4. Pi by 4 1 dx minus integral 0 to pi by 4. Pi by 4 log 1 plus tan x. Okay students, again here what is the question? Integral 0 to pi by 4 log 1 plus tan x. Here also again we got integral 0 to pi by 4 1 plus tan x. What to do again? Yes, anyone? Again we got the same integration, same given question we repeated. It's repeated. What shall we do students here? Anyone? This is log
First
2.
equation.
minus plus the second equation.
Yeah, so we can adding both the equation. Otherwise, shall I replace this is simply I? Yes, no, from equation on, what is the value of this integral? Clearly I, LHS is I. I want to replace it by I. Okay, this I you can take it to left side. I plus I, that is 2I is equal to log 2 from pi by 4 minus 0. I substituted upper limit minus lower limit. Okay, now finally I is equal to pi by 8 times of log 2. This is the required integral value.
Sir,
Required
won't it be log 2 pi by 4 minus log 2 0, sir?
Log 2 into 0 is 0 only, no? So I log 2 into 0, 0. No need to write.
Okay,
Devata,
sir.
is it clear? When you
Yes.
multiply, it will become 0. Fine. This is the answer. Any doubts what I have done? I apply the property. Without applying the property, we don't get the answer. Because we know that log x, but we don't know the integral value of log of 1 plus tan x. So here we don't have any chain rule. For example, if it is a differentiation, we can apply the chain rule. First we can differentiate log, then we can differentiate this 1 plus tan x. But when integration, there is no chain rule in integration, so that, okay, so according to the question, we can apply the property. I apply the only first property, I simplified, finally we got the answer. Nothing will be there, right? This is about that. Then next one is, okay, question number 18 is quite lengthy actually, very lengthy, but a logical question. Shall we do that question number 10? Sorry, not 18, it is 10. Question number 10. We have to do logically. If you do logical, it is otherwise lengthy. Don't write separately. See here, I'm going to do this 0 to pi by 2. So in this class, I'm planning to complete NCRT. Then the next class, I'm going to start the OBT part, right? And today we're having special class evening 5 o'clock. Today, tomorrow. Because on second, you may get holiday on Monday. Am I right, students?
Yes.
Sir.
Yes, sir.
Yeah.
The 31st only holiday.
Yes.
Sir, this Monday only holiday, sir.
Yeah, maybe. Okay, Monday is all day. So that only I'll take the special class today and tomorrow. If possible, we'll start 4:30, 4:30 to 6, or else 5 to 6:30.
Okay, sir.
Okay, right? Right. For coming to question number 10, integral 0 to pi by 2. Pi by 2, 2 times of log sine x minus log sine 2x. Okay, into dx. Okay, you should not write separately here. So see here, students, integral 0 to pi by 2. We may write in 2s. You may substitute sine 2x value as 2 sine x cos x. Or else log sine x, 2 log sine x can be written as log sine x to the square. Am I right? Minus log. Shall I write here sine 2x as 2 sine x cos x? Yes, we can write. M log A.
Is that
Log,
sine square x or sine x square?
not sine x square, it is sine square x. Okay, sine square x. We should not get the sine x square, right? Two log sine x becomes log sine square x. Not we never get. For example, 3 log sine x is there. Log sine cube x, not sine x cube. Clear, Kishore?
Yeah.
Yeah. Now again, look at here. This is in the form of log a minus log b. This is log a. This is log b. What is log a minus log b formula?
Log A by log B.
Yeah, log a by b. Okay, sin x cos x into dx. Shall I cancel here? Okay, okay. So we can cancel one sine. Then after that, okay. So we are going to get integral 0 to pi by 2. Sin get cancelled. What is the remaining value, students? Remaining value. Sin x by 2 times of.
2 cos
Okay.
x.
So yeah, fine. So here log sin x by cos x minus log 2. Shall I write like this? Shall I? Sin x by cos x, we may write tan x, no problem. If you're getting any confused, sin x by cos x is tan x by 2. By 2, am I right? Dx. Again, you may apply like log a by b formula. So 0 to pi by 2 log, left side is log tan x minus log 2 into dx. Let us take this as equation 1. Fine. So what I have done, I just till now I didn't apply any property. Just I applied properties of logarithms. I simplified. Finally, we got like this. Now I am going to apply the property, that property 3. That is 0 to a f of x dx. It is equal to 0 to a f of a minus x dx. Got it? Right. From this, I is equal to like integral 0 to pi by 2 log tan 90 minus x minus log 2 as it is, okay, into dx. See students, I want to adding these two, adding 1 and let us take this is 2. So left side is whenever adding left side I plus I plus I. What is the common in these two? The common is 0 to pi by 2, 0 to pi by 2. Dx. That's all. So integral 0 to pi by 2, from the equation 1 log tan x, from equation 2 plus log, what is tan 90 minus x? Shall I write cot x? From equation 1, minus log 2 is there. Whenever we are adding from equation 2, we are going to get one more log 2, right? Into dx. See, is it clear, students? I'm adding. I'm taking the common values, integral and dx, remaining values I'm adding. See, this is in the form of log. Left side it is 2i, right side 0 to pi by 2. Log a plus log b. I want to apply log a plus log b. Log cot x. Tan x into cot x minus 2 log 2 into dx. Student, what about this value, Amma? Cot x into tan x. Value becomes?
1.
Okay, it is 1. What is log 1? Log 1 always
0.
0. So finally this value becomes 0. Then remaining 2 times of I is equal to this here 2 log 2 minus times of 2 log 2. Clearly 2 log 2 is a constant, take it outside into dx, 0 to pi by 2. Is it clear? 2 log 2 is a constant, completely I'm taking outside. Then get 2 to get cancelled. I is equal to minus, okay, fine students, minus this log 2 times of upper limit minus lower limit, pi by 2 minus, sorry, this is equal to, actually we get minus log 2 times of x, because the derivative integral get cancelled, 0 to pi by 2. So substitute upper limit minus lower limit. Got it? So here the answer will be I is equal to minus pi by 2 log 2. Pi by 2 log 2. What is the answer they have given? This is the absolutely right answer. Once you look at the answer, NCERT answer. Clear? Yeah, we may also, this can, in case if you want, you can write like this. Pi by 2, you can take a minus inside log 2. Shall I write this value is pi by 2 log 2 power minus 1. Pi by 2 log 2 power minus 1 is log 1 by 2. We may write in 2-3 ways answer. So above one is correct, below one is correct. I don't know what is the answer they have given in textbook. So what is the book back answer, Amma?
Minus pi by 2 log 2.
Yeah. So like question number 13. Remaining you have to do, students, like this is also easy. Sine square. Sine square means sine square is even function. Okay. I'm going to explain you the question number 13, because it is odd function directly 0. Whenever it is odd function, you know, it just becomes 0. 13th steps, how will you write the steps? So 13th one is, let us take here f of x is equal to sine to the power of 7x. You have to find f of minus x. Minus x means sine to the power of 7 into minus x. Sine is an odd function, sine power 7 is also an odd function, so it can be written as 7x. So f of minus x is equal to minus f of x. Therefore, f of x is odd function. Okay, therefore here integral minus pi by 2 to pi by 2 f of x dx, that is f of x nothing but minus pi by 2 to pi by 2 sine to the power of 7x dx is becomes 0. For every odd function, if the limits are, okay, when it will becomes 0, when the limits are same and opposite sign. Many times I repeated this word. Okay, when the limits are same and opposite sign, for odd function, the integral value becomes directly 0. Clear, students? Okay, ma. 14th one is clearly even function. 14th one is cos to the power of 5 is clearly even function. What shall we do here? There is a property, it is same like integral 0 to 2a f of x dx. Okay, let us do the 14th one. 14th one. I is equal to integral 0 to 2 pi cos to the power of 5x dx, right? Cos to the power of 5x dx. Let us take this as equation 1. Okay, see, since there is a formula like integral 0 to 2a f of x dx can be written as integral 0 to a f of x dx plus integral 0 to a f of 2a minus x into dx. Now I am going to find this f of 2a minus. I want to check what is the value of that f of second value. What is 2a value? 2a value is 2 pi. F of 2a minus x is equal to f of 2 pi minus x is equal to that we have to substitute here 2 pi minus x. Students, anyone, what about the cos 2 pi minus x? Yes. What is cos 360 minus theta?
Sine power 5x.
Sin power 5x? Yes, anyone? Is it sin power 5x? Or cos power 5x?
Cos power.
It will be cos. Okay, burning. Is it clear?
Yes, sir.
It was miss.
Yeah, so it is clearly cos to the power of 5. Okay, students. 360 minus theta, 360 plus theta, 180 minus theta, 180 plus theta will get the same function. Whatever we are giving input, output also same. So this is okay. This is belongs to which quadrant? Quadrant 4. Quadrant 4 cos is positive. Then cos power 5 also positive, right? So this is cos power 5 x. Finally, so here with help of this, whenever this is f of 2a minus x is equal to clearly f of x. F of x I'm taking as cos.
How do we
Yes.
know 2 pi minus x belongs to quadrant 4? Because x could be greater than 90, right?
Yeah. Is it they have yeah. Is it they have mentioned anything like x is greater than, yeah, x is greater than 90?
No.
Do they given any interval like particular domain? They do not given any domain. In case if they give like x is greater than pi by 2, that time we can't say, right? They do not given anything, so that just it is a variable. Just you have to think about this 2 pi minus x,
Okay.
right? Okay, fine. So finally, f of 2a minus x is equal to f of x. Therefore, according to this 0 to 2a f of x dx is equal to, it can be written as 2 times of integral 0 to, yes, 0 to a f of x dx. Because, why can't we apply direct to the third property here? Like, why can't we apply? So if we apply the direct property, again we'll get the same function. Got it? If you apply the third property, I told you third property is important, 0 to a f of x dx. If you apply the third property, again we'll get the same cos power 5. The value cannot be changed. So we cannot find, we cannot evaluate. If we get different values, then we can adding something, we can do something. But if we get the same value is repeated, again no use. So that with help of this property 0 to 2a f of x, I have written 2 times of 0 to a f of x, because here f of 2a minus x is equal to f of x. Then only you have to take 2 times of 0 to a. Okay, if it is an odd function, this integral becomes 0. Here cos power 5x, we got even function means same value. So that the given I is equal to 2 times of integral 2a can be written as this 2 you can take in here. When I multiply this 2 into a, 2a. So in the same here also pi. Okay, given question 0 to 2 pi, but I am taking 0 to pi cos power 5 x dx, right? Now this is, let us take equation equation 2. Equation 2. After applying the property 0 to 2a, we got 2 times of 0 to a f of x dx. Now I am going to apply the property 4, that is 0 to a f of x dx is equal to integral 0 to a f of a minus x into dx. Got it, students? So now it will become 2 times of 0 to pi, as it is cos to the power of 5 pi minus x into dx. Anyone can say the value of cos to the power of pi minus x, students? What about this value?
Minus cos power 5x.
Exactly, minus cos power 5 pi minus x. Got it? Because cos 180 minus x is minus cos x, but all to the power of 5 will be there. All to the power of 5, but don't think that here, like I'm not checking cos is even. Generally the student think that cos is even, but according to the interval, right? So interval 0 to pi, so here we got minus, so this is equal to like not again pi minus x. So cos to the power of 5 x dx. Okay, let us take this is equation 3. Now I am going to adding equation 2 and 3. When adding equation 2 and 3, LHS is I plus I. RHS, what are the common here? What are the common in both the equation? 2 is common, integral 0 to pi is common, dx is common. 2 common, integral 0 to pi is common, cos power 5x. If from the equation 3 minus cos power 5 into x into dx. These are the common. So what is the answer here? 2 times of integral 0 dx. What is integral 0 dx, sum? Anyone? Integral 0.
0.
So 2 times of 0, so that is nothing but 0. Finally, I is equal to 0. Can you can you check the answer for this question? What is the output here? Is it 0? You know why the area becomes 0? Generally, if for any curve, if you take any two limits, generally it should not be 0. But here we are getting 0. Why? What is the reason that it is becomes 0? For example, when you take the sin x or cos x something, sin x or cos x. Okay, if we draw the graph of sin x, generally we are getting x sin 0 0. This is 0. This is 90. This is 180. The area becomes like this. Okay, fine. When you take the cos value, in case I'm going to draw the cos function, why the area becomes 0? Because here we found the cos power 5 from 0 to pi. Let's see here why it will become 0. What is cos 0? 1. What is cos 1? Here minus 1. What is cos 90? 0. Cos 180 is minus 1. So when you see that here we are with respect to x-axis, they are asking in the given question also, they are asking the integral value from where to where? 0 to 180 cos power 5. 0 to 180, 0 to 90, we are getting the area in first quadrant. But when you see the here 90 to 180, the area we are getting in fourth quadrant, right? So generally the area I'm taking in first quadrant is A1, in fourth quadrant is A2. Remember students, the area generally in first quadrant it is positive. Nothing but Above x-axis we are consider the area is positive. Below x-axis we are consider the area is negative. So A1 plus A2 with the total area. For example, A1, A2. What about the area of A1? Clearly look at your students. If A1 area is some 10 square units, A2 also clearly equal to 10 square units, but it is negative below x-axis. So 10 minus 10, it will become 0 like that. This is the reason. This is the reason. The year 0 to pi cos power 5, the area becomes 0. Above x-axis, the area becomes positive. Below x-axis, the area becomes negative. Got it? Like that, here area becomes 0. This we will discuss in next chapter, that is applications of integration. In all the problems, we are going to find the area alone in applications of derivative, right? Applications of integral, next chapter. Students, then you can do this, you can try to do this 16th one. 17th one, directly the answer is a by 2. I told you very clearly. Apply the first property. This is, let us take equation 1, I is equal to, apply the first property, integral 0 to a. First property is a minus x by a minus x. A minus x become like this dx. This is 2. When you're adding this, left side is I plus I, but right side denominator is root x plus root over a minus x. Numerator also root x plus root over a minus x will get, surely will get. Both will get cancelled. 2i is equal to integral 0 to a 1 dx. 1 nothing but x from 0 to a. Here that is nothing but a minus 0. So 2i is equal to I is equal to a by 2. Simple students, apply the property 4. This question already we done. What is the answer we got it in this question? Question number 20. Yes, students? Forgot whether we completed or not.
Computation.
Pi, because odd function becomes 0 because limits are same opposite sign. You have to integrate just one alone. Okay. Next, coming to 19th one, I will finish it 19th one. So this is like a is very easy question, but don't think that it is difficult. It is very easy, but they do not given any function to evaluate the integral value. But they have given few conditions like f of x is equal to f of a minus x, g of x plus g of a minus x is equal to 4. Okay, let's see now. So I'm going to take this given condition and I want to apply. So what is the apply the property 3. Can anyone tell that what is the question here? Integral 0 to a 2 times of integral 0 to a f of x dx they have here. What I want to do, I want to apply the first property here, LHS. 0 to a, let us take this is equation 1, no problem. When I apply the first property f of a minus x, g of a minus x dx is equal to what? So clearly, fine. See, right side is 2 times of integral 0 to a f of x dx. But given condition, what is the condition they have given? F of a minus x value is clear again. F of x, got it? Yes and f of a minus x value is f of x. We can replace here. So integral 0 to a. This is f of x. G of a minus x into dx is equal to 2 times of 0 to a f of x dx. Now see here one more condition they have given g of x plus g of a minus x. To get g of x plus, yeah, g of x is there, g of a minus x is there. Let us take these two. To get a g of, yeah, g of x plus g of a minus x, we can add in both the equations. Adding both the equations, 1 plus 2. 1 plus 2. Here clearly left side is integral 0 to a f of x is common, but here it is from equation 1 g of x, from equation 2 g of a minus x into dx. Right side is 2 times becomes 4 times of 0 to a f of x dx. Got it? What about this value of g of x plus g of a minus x is equal to, they have given, got it? Okay. So here we will get here 4 you can substitute, 4 you can substitute here. So 4 you can take it outside. Okay, then hence we proved here. Hence we proved, so we'll do one thing, students. When I take here, this is I. This is I. This is also I. I plus I. This is 2I is equal to this value. Fine. So 2I is equal to, yeah, 4 times of 0 to a f of x dx. What is the question? Okay. Sorry. Show that. They asking show that. We proved. Actually proved here. 2a is equal to this 2 dx. That is nothing but this is equal to 0 to a f of x dx. Hence proved. I'm taking LHS. We proved RHS. This is RHS. Got it? Here no need to take here. We have to prove, so that don't take this right side value. I apply the property. I'm adding both the values. Hence we proved. This is RHS. I'm taking LHS. We got the RHS. Hence proved. Okay, got it, students? You can try to do the remaining questions. All are easy only. In case if you are unable to get any answer, I'll explain you. We'll start next period is OBT. Okay, ma'am. We'll wind up the class.
Thank you, sir.